I'm Michael Davies. I'm a research analyst at Green Econometrics, and I'm here today to follow up on our prior discussions on the electric vehicle market. So in our prior segments, we began with looking at the economics of EVs, specifically in comparison to combustion engines. We found that there's a substantial savings to be had employing EV charging over that of electric vehicles, as well as the different levels of charging and the time frame involved, how long it takes to charge that vehicle using different approaches. Our next segment dealt with the direct current fast charge approaches for EV charging and the high intensity of these endpoints, specifically a commercial building in a box, if you will. This provides challenges for grid long distance communication to support high intensity endpoints. And our third segment revolved around the National Electric Vehicle Infrastructure Plan. This was the bipartisan approach to installing 500,000 stalls across the country, and what the impact that will have on both the demand and consumption of energy for the grid itself. We explored the limitations of renewable energy around helping EV charging stations, given the energy intensity of these stations themselves. So today, we're here to follow up with the EV charging with the focus on the battery, and specifically the battery technology and the vehicle-to-grid charging capabilities, which could help mitigate some of the concern around support of the grid. Namely, though, we're going to focus on the supply chain for batteries, essentially the metals that play a role in the construction of the battery itself. And so I'll jump into some charts on that to help better explain it. But before I do, let's look at some of the takeaways here. Bottom line is battery technologies have not evolved as quickly as other technologies, like Moore's law applying to semiconductor production. So with that, there's limited commercial use of some of these newer approaches to batteries. Secondly, because most of the metals used in battery consumptions are mined in countries other than the U.S., there's limitations of what countries will play a role. Namely, countries with fair trade agreements with the U.S. are favored for any incentives under the new program for funding of technologies applicable to electric vehicles. The battery supply chain is limited because some of these metals are rather rare and costly. There is limitation and some possible constraints on the supply chain itself. Again, this vehicle-to-grid capabilities, both of the vehicle and into the infrastructure of the grid, could play a significant role in mitigating some of those concerns. So with that, if we jump to one of the approaches here and share the screen, let's first look at the battery technologies. And with the battery technology, we are measuring this in watt hours per kilogram. So essentially, it's how much power do I get to the amount of weight. And from what we found is that battery technologies, I mentioned, evolved rather slowly, starting with lead acid batteries, in the beginning of, time here before 1960. And then we came to the nickel cadmium and then to lithium-ion in the last couple decades. New approaches such as lithium metal play a key role in bringing that weight and power up and weight down of the battery. So this will be instrumental in moving this forward. And again, if we look at these metrics in comparison to oil, gas, or hydrogen, batteries are just overweight in comparison to the energy they provide. So that is the basic constraint that we have. And it's manifested in the in the supply chain itself. But before we get there, let's just look at this vehicle-to-grid approach. This is V2G, and essentially it's a capability within the car itself. The vehicle has to have that capability to push power out of the car into home charging system, or more importantly, how to make this commercially viable. So the grid infrastructure has to be part of the equation as well. So it's essentially bringing power from the vehicle to the grid, has to be done in mass. It can't just be done with one vehicle. So these are things to look for as we move forward. And now let's just take a look at the supply chain. So for battery production, you have four basic metals comprising the batteries in electric vehicles today: lithium, nickel, cobalt, manganese. And their abundance is related to what you're paying for them, the price per metric ton. We see that manganese is rather abundant, so it's relatively less expensive than cobalt, which is not relatively abundant. Nickel and lithium are primary metals, and again, it's, where are these things found? And it's not only the mining of the metals, but also of the processing to make them into batteries themselves. And so what we find is that there's a handful of countries that have core capabilities in certain metals. And namely, again, those countries that have fair trade agreements, they're going to be Australia, Chile, and Canada, namely the ones on this map here. And from what we found is that, most of this is concentrated in China in terms of processing. So the availability of the metals and the ability to actually process them and turn them into batteries. So what we see is that China not only has a leading position in the processing of these rare metals, but also the largest supplier of batteries to electric vehicles. So this is the constraint that follows the electric vehicle market. How rapidly can we bring production here to the U.S. With emphasis on a reliable supply chain, as well as production to get better support to grow the industry? Thank you.